Welcome to the deep dive. Today, I want you to maybe think for a second about the silent powerhouses, the things enabling our modern world. Those tiny, often unseen components making our devices super efficient, really precise. Have you ever wondered what's really making your car's power windows just glide up and down so smoothly?
Or, yeah, the tiny movements inside a complex medical robot.
Exactly. Or even like the subtle mechanics in your smart home gadgets. What's the sort of secret sauce behind that seamless, accurate operation?
Hmm.
Well, today, our deep dive is into a market that, okay, it might sound quite niche, but it's absolutely foundational. We're talking about the control unit for Brushless Micromotor Market.
Right, brushless micromotor. Sounds very technical.
It does, doesn't it? But here's the gist. Unlike older motors that use physical brushes to transfer power, these brushless ones use magnets and electronics.
Which means they run smoother, they're way more efficient, they last longer, and they can be incredibly small.
Precisely. And it's their control unit. You can think of it as the motor's highly intelligent brain, really.
That's a good way to put it.
It precisely manages its speed, its direction, the power, making sure it performs exactly as needed, from slowly raising a car window to precisely moving, say, a surgical tool. These control units are truly the unsung heroes.
Absolutely. Critical stuff.
So our mission today is to pull out the key insights from the Brushless Micromotor Control Unit Market Forecast 2033 source. We want to unpack the surprising scale of this market, its projected and, frankly, kind of astounding growth, and what's really driving it all. Okay, let's get into it.
Let's do it.
So, to give you a real sense of the scale we're talking about here, back in 2021, the global sales revenue for these control units, it was already over $1 billion US.
Oh, okay.
Specifically, about 1,055.1 million. But here's where it gets really interesting. By 2025, that figure is projected to jump pretty significantly. We're talking $1,452 million.
Okay, that's quite a leap in just a few years.
It is. That's showing a really strong compound annual growth rate, or CAGR, of 8.31%. And looking even further ahead, out to 2033, the market isn't just growing, it's expected to more than double its 2021 size.
Double.
Yeah, surging to nearly $2,750 million, almost $2.8 billion.
That's huge.
And this incredible expansion, it isn't isolated. It's happening across key sectors like automotive, consumer electronics, industrial automation, and healthcare.
And, that doubling in size by 2033, it isn't just some number on a spreadsheet, is it? It really reflects a fundamental shift.
Right.
What's fascinating here is that this growth isn't just about, general tech getting better. It's deeply rooted in the increasing global demand for devices that are not only compact and powerful, but also highly energy efficient.
Ah, the efficiency angle. That makes sense.
Think about it. An electric vehicle needing every bit of power optimized, or a tiny surgical robot where precision, with minimal energy use, is literally life-saving.
Yeah, absolutely.
These control units are just central to delivering that kind of performance.
Yeah.
So as industries push for more sustainable and high-performing solutions, well, this market is naturally going to explode.
Speaking of explosion, let's zoom in on where a big chunk of this growth is actually happening.
Okay.
Asia Pacific. It isn't just contributing, the source highlights it as the absolute powerhouse driving this market.
Right.
In 2021, the region's revenue was $383 million. By 2025, that's set to reach nearly $530 million. And, remarkably, is projected to surpass $1 billion by 2033.
$1 billion just in Asia Pacific.
Just in Asia Pacific. With an impressive 8.96% CAGR, it's a pretty staggering rate.
It really is.
And within Asia Pacific, China really leads the charge. It grew from $147.5 million in 2021, projected to hit a remarkable $422.3 million by 2033.
Wow.
That's boasting a 9.52% CAGR. India isn't far behind either, showing equally impressive growth. It's effectively doubling its market size from $65.5 million in 2021 to $193.8 million by 2033.
Almost the same CAGR, 9.49%.
That's interesting.
Yeah, very close. And we also see strong, consistent contributions from Japan, South Korea, Australia, Singapore, Southeast Asia, and Taiwan.
So it really begs the question, doesn't it? What specifically makes Asia Pacific such a dominant force here?
Good question.
It feels like it's more than just manufacturing hubs, Think about China's Made in China 2025 initiative, heavily emphasizing advanced robotics, smart manufacturing.
Right, automation.
Exactly. It's not just about producing more, it's about producing smarter and more automated. And that directly translates to a massive demand for precise motor control right there on the factory floors.
Makes sense.
And then in India, beyond just general industrialization, we're seeing this rapid leapfrogging in technology adoption, particularly in consumer electronics and the automotive sectors.
They're not just adopting existing techs, they're integrating advanced components into their growing domestic production. So yeah, it feels like a combination of aggressive industrial policy and, well, a booming consumer base that really sets their growth apart. What do you think that means for their long-term spot in this market?
It really sounds like they're setting the pace, doesn't it? Definitely positioning themselves strongly for the future. Okay, moving across the globe, North America also making a very solid contribution to this market.
Yeah.
Back in 2021, the region generated roughly $287 million. This is forecasted to grow to over $383 million by 2025.
Mm-hmm.
And then further out to $701 million by 2033. So still showing healthy growth, a CAGR of about 7.84%.
Still respectable growth.
Absolutely. And looking at the countries within North America, the United States, well, naturally leads. Sales there are projected to reach $528.4 million by 2033.
The lion's share.
Pretty much. Canada is also expanding significantly, though. Aiming for nearly $100 million by 2033, that's an 8.23% CAGR. And Mexico is projected to see strong growth too, hitting about 72.9 million by 2033.
You know, what stands out for North America, I think, is while it has robust growth, the underlying drivers feel subtly different from Asia Pacific.
How so?
Well, here the demand seems often driven by highly sophisticated applications, maybe more focus on cutting-edge innovation.
Okay, like R&D heavy sectors.
Exactly. Think about the sheer volume of R&D in the United States, particularly in areas like advanced medical devices, aerospace, high-performance EVs.
Right?
That means a constant need for the most precise, the most reliable, the most compact motor control units available. Plus, regulatory environments, especially in healthcare, often push for higher specs, which these advanced control units deliver.
Ah, so it's less about sheer volume manufacturing, perhaps, and more about quality and advanced features.
Maybe pushing the boundaries of what these micromotors can actually do. How do you see that influencing the specific types of control units being developed in North America versus, say, Asia?
That's a great point. It probably means a focus on, higher integration, maybe more complex algorithms, specialized features for those demanding applications. It really highlights that qualitative difference in demand. Okay, shifting our focus now to Europe, we see another strong market here, one that's steadily expanding.
Right.
The region started at roughly $227.9 million back in 2021, and it's expected to surge to $569.2 million by 2033.
So more than doubling as well.
Yes, growing at an impressive 8.12% CAGR.
Very solid.
Germany, no huge surprise there, holds a substantial share. It's projected to more than double to 125.8 million by 2033.
Makes sense with their industrial base.
Definitely. The United Kingdom is also expanding steadily, looking to reach nearly 60 million by 2033. But what's particularly interesting, I thought, was the rest of Europe segment. Yeah, it stands out with a really robust 9.12% CAGR, projected to hit 113.3 million in 2033.
Higher than the overall European average.
Exactly, which indicates, I think, a really broad adoption of these technologies across diverse European economies, not just concentrated in a few major players.
That's interesting.
And of course, countries like France, Italy, Russia, Spain, the Nordic nations, they also show consistent growth.
If we sort of connect this to the bigger picture, Europe's consistent expansion really underlines its global leadership in things like precision engineering and industrial automation.
Industry 4.0 and all that.
Precisely. Think about Germany's Industry 4.0 initiatives. It's all about smart factories, highly automated production lines. And those are heavy users of these brushless micromotors.
Right.
The demand isn't just for efficiency, it's for those exacting standards of precision and durability that European manufacturing is really known for. And that strong growth in the rest of Europe, like you said, it really tells a story of widespread digital transformation, these automation initiatives spreading across the continent. It also suggests a pretty healthy ecosystem of specialized companies needing these advanced components.
Yeah.
Do you think that widespread adoption maybe indicates a more mature or diversified market compared to, say, some of the faster-growing emerging regions?
I think it absolutely does. It speaks to a mature industrial base that just keeps innovating and integrating new tech. Okay, finally, let's explore the emerging markets. South America, the Middle East, and Africa, each charting their own sort of unique growth paths.
Right, starting from smaller bases, presumably.
Exactly. South America's market reached about $66.5 million in 2021, but it's projected to grow significantly over $203 million by 2033. That's an 8.49% CAGR, quite strong.
It is strong.
Brazil leads the region, nearly tripling its market size by 2033. And you also see contributions from Argentina, Colombia, Peru, Chile. The Middle East market is also expanding, though maybe at a more moderate pace compared to others. From 48.5 million in 2021 to about 112.7 million by 2033. That's a 6.76% CAGR.
Still growing, but yeah, a bit slower.
Saudi Arabia is a key player there, along with Turkey, UAE, Egypt, and Qatar.
Makes sense with their economic diversification pushes.
Yes. And lastly, Africa's market is gaining traction, projected to grow from $42.2 million in 2021 to almost $110 million by 2033. That's at a 7.65% CAGR. Nigeria and South Africa are noted as key contributors here.
You know, what's fascinating about these regions, South America, Middle East, Africa, is how their growth, even starting from a smaller base, it seems to reflect some significant underlying development and diversification trends. In South America, particularly Brazil, you've got increasing industrialization, automation in sectors like mining, agriculture, manufacturing.
Yeah.
That's creating new demand.
Right, new applications opening up.
The Middle East's expansion, even if moderate, could be tied to those huge infrastructure projects, the economic diversification efforts away from oil, pushing for modern industrial and healthcare capabilities that rely on this precision machinery.
Good point.
And Africa's traction, well, it speaks to an emerging embrace of modern consumer technologies. Maybe nascent industrialization started to take hold.
Yeah.
This kind of raises an important question, doesn't it? As these economies continue to mature and integrate more into global supply chains, could their demand for these foundational components eventually accelerate at rates we haven't even fully accounted for yet?
That's a really interesting thought. Potential for even faster growth down the line. So, wrapping this up, what does this all mean for you, the listener, and maybe for the broader tech landscape? When we look at all these numbers together, the global projections, the regional breakdowns, the Brushless Micromotor Control Unit Market Forecast 2033, it just clearly points to a robust and, well, undeniably optimistic global growth story.
Definitely optimistic.
The increasing demand for highly energy-efficient, compact, precise motor control, coupled with ongoing tech advancements making these units even more capable. It really paints a picture of a sector with immense momentum through 2033 and likely beyond.
Exactly. And these tiny, yet absolutely critical control units, they underpin so much of the tech we rely on every day for efficiency, for performance, often without us even realizing it.
The hidden intelligence.
That's it. They're the hidden intelligence making our world run smoother.
So, given this strong, steady growth across such diverse regions and industries, I want you, the listener, to consider something as you go about your day. What new frontiers might brushless micromotors and their sophisticated control units unlock beyond their current applications in the next decade? Could we see them revolutionize areas like, say, sustainable urban mobility, or personalized robotics for the elderly, or maybe advanced climate control systems that are far more precise and efficient than anything we have today?
Interesting possibilities. What surprising innovations might emerge from this seemingly niche but actually profoundly foundational technology? Something to think about. Welcome back to the Deep Dive. Today, we're plunging into a world you might not even know exists. We're talking about the highly specialized control units, the brains, really, behind tiny, high-precision, brushless motors. Now, these unseen devices are absolutely crucial. Think everything from cutting-edge surgery, like precisely driving a drill for a dental implant,
Yeah.
all the way to the incredibly tiny gears in maybe your favorite high-end watch.
Exactly. It sounds niche, but it's everywhere.
It is. It's a niche but rapidly evolving sector. And these hidden pieces of tech are truly critical to daily life and, well, some of the most advanced work being done right now.
That's right. And for this deep dive, what we've done is extract the most important sort of nuggets of knowledge from our sources. Our goal really is to give you a shortcut, a way to get well-informed about this particular market pretty quickly. We'll uncover some genuinely surprising connections and key insights along the way.
Okay, let's unpack this then. So when we look at what's really driving growth, what's pushing this market forward, It seems clear there's this huge rising demand in medical applications,
Mm,
specifically dental and surgical uses.
mm, definitely.
And you know why brushless micromotors are so favored here? Well, unlike the older motors, the ones with brushes that wear out and create friction.
Right, the maintenance issue.
Exactly. Brushless ones are like having these tiny, silent, almost perpetual motion machines. They operate nearly silently and give you incredibly precise, really consistent control.
That lack of vibration and noise is key in delicate work.
Absolutely essential for dental practices and, crucially, in minimally invasive surgeries. So as the number of these delicate procedures increases globally,
Yes, they are.
so does the need for these sophisticated control units,
Hmm.
the ones that can finally adjust speed and torque. And that ties directly into, optimal performance and, maybe most importantly, patient safety.
Yeah, and what's truly fascinating here is how that medical need for precision. It isn't just a niche requirement. It's actually a driving force for innovation that kind of spills over into other areas you might not expect.
Ah, okay.
This critical need in medicine, it mirrors the demands you see in precision engineering and manufacturing. Just think about it. Industries like aerospace, electronics, even, as you mentioned, high-end watchmaking, they rely so heavily on micro-drilling, polishing tasks.
Right, tiny, precise movement.
Exactly. And they need highly accurate micromotor control for that. That's where these programmable control units offering real-time feedback become indispensable. Imagine the unit just constantly monitoring everything, the motor's temperature, its exact speed, even how much resistance it's hitting.
Like it's thinking for itself.
Almost, and instantly adjusting, like an expert driver constantly fine-tuning their steering in a critical race. These tools let manufacturers meet really strict quality standards and, frankly, enhance productivity quite significantly.
And here's where, for me, it gets particularly interesting. We're seeing these huge technological advancements, digital control, connectivity.
Hmm.
They're right at the forefront now.
Yeah, the tech integration is accelerating.
Modern control units, they're now equipped with things like touchscreen interfaces, wireless connectivity, Bluetooth, Wi-Fi, and even memory storage for procedural configurations.
So you can save your settings.
Exactly.
Yeah.
And these aren't just, flashy add-ons. They radically improve how people interact with the devices. They streamline the work dramatically. Imagine a dentist being able to quickly switch between preset drilling speeds for different, say, tooth densities with just a tap.
Or an engineer loading routines wireless.
Right. Or an aerospace engineer wirelessly uploading precise polishing routines right from a tablet. These features, they're making these units incredibly appealing to more tech-savvy users. It's a real upgrade to the user experience and operational efficiency.
Absolutely. That digital layer is a huge draw, no question. It feels like the future. But even with all that innovation, we do need to be realistic about some of the roadblocks this market is still navigating.
Okay, challenges.
And the first big one that often comes up is, well, the high cost. Advanced control units, especially with all these complex digital features, enhanced safety mechanisms, they just come at a high
It's a
price.
significant investment.
It really is. We're talking about an investment that can easily put them out of reach for, say, smaller independent dental clinics, or maybe a single craftsman trying to start a high-precision workshop, especially in emerging economies. It's not just a line item on a budget. It can be a genuine barrier to entry for many.
Yeah, and it's not just the initial purchase price, is it? We're also looking at operational complexity.
Good point.
Think about it. Operating these sophisticated units often requires specialized training. You can't just hand it over. Without adequate knowledge, users risk equipment malfunction or maybe just underperformance.
Which can impact the final quality.
Yep.
Exactly. Which can directly affect the overall workflow, compromise the quality of their work, and potentially even impact safety in those critical environments. It's not a tool you just pick up and intuitively master right away.
No, definitely not. And another challenge that's surfacing is compatibility, or lack thereof sometimes. Some newer control units. Well, they aren't backward compatible with legacy micromotors or attachments.
Ah, so your old tools might not work with the new brain.
Precisely. It often happens because the new units might use different digital communication protocols, maybe different physical connections that just don't match the older equipment. And this forces users into complete system upgrades, which of course ramps up the costs again.
Right.
And potentially slows down market penetration, particularly with places still reliant on older but maybe still perfectly functional equipment.
Okay, so cost, complexity, compatibility, those are hurdles. But looking ahead, there are some incredibly exciting trends really reshaping this market.
Definitely, the innovation isn't stopping. First up, The integration of the Internet of Things, IoT. This feels potentially revolutionizing. Just imagine the possibilities here. Manufacturers are embedding IoT functionalities. Think real-time performance monitoring, remote diagnostics, even predictive maintenance.
So the machine tells you when it needs looking at.
Exactly, before it breaks down.
Yeah.
This means a control unit could literally signal that it needs a service before a failure occurs. Think about minimizing downtime for critical procedures, extending the equipment's lifespan, reducing operational costs. It's a huge win for any facility relying on continuous high-precision operations.
That predictive element is powerful. And alongside that digital leap, another notable trend is the push towards more compact and ergonomic designs.
Making them easier to handle.
Right. Lighter, space-saving control units, often with more intuitive interfaces, they're gaining significant popularity. You see this especially in clinical and industrial settings where, mobility and ease of use are really critical.
Exactly.
These designs help reduce physical strain on operators, especially during long procedures, and they streamline workflows. That's a big deal when you're working with such fine precision for hours on end.
Absolutely. And finally, one more trend.
Yeah.
We're seeing customization and modularity really take center stage.
Tailoring the tool to the task.
Precisely. There's this increasing demand for control units that can be tailored specifically to certain tools and applications. So what this means is you get modular systems, systems with customizable presets, interchangeable components. They offer incredible flexibility and adaptability.
So you don't need a whole new system for every different job.
Exactly. Users can optimize their setups for really diverse tasks without having to replace entire systems. It's like building a precision tool that's perfectly suited to your unique needs. So, okay, what does this all boil down to? We've seen how the control unit for Brushless Micromotor Market is, well, it's evolving fast, really fast. It's driven by those expanding medical and industrial needs we talked about, coupled with some really exciting technological innovation and a strong focus on user-centric design, making them easier, more intuitive to use.
Right. Despite the challenges.
Yeah, despite those challenges like high cost and compatibility issues. The innovations we're seeing, IoT integration, ergonomic improvements, that modularity, it really does point to a bright future for these unseen yet utterly essential precision powerhouses.
It really does. And, this raises an important question for you to think about. Considering this big push for customization and modularity, how might future innovations in these control units not just optimize the applications we already have, but actually unlock entirely new possibilities, new kinds of precision work that maybe we can't even imagine yet? What hidden capabilities might they reveal in the tools and the tasks of tomorrow?
It's a truly thought-provoking idea, isn't it? Food for thought.
Yeah.
Well, thank you for diving deep with us today into the incredible, often unseen technologies that shape our world. Until next time, keep exploring.